Hello everyone. My name is Tao Han. I'm going to present our research on addressing the scale variations issue for objects counting and localization with the proposed selective inheritance learning. Scale variation is a challenging issue that widely exists in computer vision tasks. Our solution is based on the two motivations. First, we disentangle each resolution into scale. Customized and scale. Uncustomized and scale. Uncustomized features before each fusion, enabling them to be independently processed. Second, we need a dedicated module to select which objects are more tractable at each resolution and optimize them in the corresponding resolution. The contributions can be summarized as follows. 1. We introduce Steerer, a principled method for object counting that resolves scale variations by cumulatively selecting and inheriting discriminative features from the most suitable scale, thereby enabling the acquisition of scale, customized features from diverse scales for improved prediction. Accuracy. 2. We propose a feature selection and inheritance adapter that explicitly partitions the lower scale feature into its discriminative and undiscriminating components, which facilitates the integration of discriminative representations from lower to higher resolutions and their progressive transmission to the highest resolution. 3. We propose a masked selection and inheritance loss that utilizes the patch winner selection principle to select the optimal scale for each region, thereby maximizing the discriminatory power of the features at the most suitable scales and progressively empowering CA with progressive constraints. The proposed selective and inheritance learning based on multi-scale network design, hierarchical optimization, and reasonable scale selection criteria. Multi-resolution features are commonly adapted in deep learning algorithms to capture multi-scale objects. The feature visualizations in the red boxes depicted in this figure demonstrate that lower resolution features are highly effective at capturing large objects, while higher resolution features are only sensitive to small-scale objects. Therefore, building multi-resolution feature representations is critical. From the four-feature map in the middle of the figure, we can see that the feature of large objects in level 3 is the most aggregated and most dispersive in level 0. Directly upsampling the lowest feature and fusing it to a higher resolution has two drawbacks, and we propose FCI to handle them. 1. The upsampling operations can degrade the scale, customized feature at each resolution, leading to reduced confidence for large objects. 2. The dispersive feature of large objects constitutes noise in higher resolution, and vice versa. The CFON is responsible for combining the upsampled scale, customized features. The UFON, on the other hand, continuously forwards scale, uncustomized features to higher resolutions since they may be potentially beneficial for future disentanglement. If these features are not necessary, the UF can still suppress them, minimizing their impact. The SEMG actively identifies and generates two attention maps for feature disentanglement. FCI is supposed to be trained toward its functions by imposing some constraints. Finally, we propose inheritance loss to activate the FCI. Take the fusion process at the R2 and R3 level as an example. Inheritance loss enables SMAG module to disentangle the R3 resolution. Simultaneously, it also ensures that the fused feature R2, which combines the R2 level with the scale, customized feature from R3 retains the ability to provide a refined prediction as achieved by the R3 level. The remaining AFCIs operate similarly, leading to hierarchical selection and inheritance learning. Finally, all objects are aggregated at the highest resolution for the final prediction. Another crucial component in the inheritance loss is about how to determine the right region mask for each resolution. To achieve it, we propose a patch winner selection principle, POWSP, to let each resolution select its capable region, whose thought is to find which resolution has the minimum cost for a given patch. During the training phase, each resolution outputs its predicted density map. POWSP dynamically gets the region selection label SPI, Okay, this figure shows that SPI, car transferred to mask M with a one-hot encoding operation and an upsampling operation. The ultimate optimization objective for steerer is a accumulated loss weighted on all branches. Steerer is comprehensively evaluated with object counting and localization experiments on 9 datasets. NewPew Crowd Benchmark is a challenging dataset with the largest scale variations, which provides a fair platform for evaluation. Tab. One compares steerer with the can-based sodas. Steerer, based on VG19 and the Harnett backbone, both outperform other approaches on most of the counting metrics. On the whole, steerer improves the MAE across all the subcategories, except for the zero level and overall dataset consistently. Benefiting from its high resolution and elaborated density map, steerer can use a heuristic localization algorithm to locate the object center. Specifically, we extract the local maximum as a head position from the predicted density map. Table 3 tabulates the overall performances by comparing the primary key. Phone measure. For ranking, our method achieves first place on the phone. Measure 77.0. 77.0 compared with other crowd localization method. Table 4 demonstrates that steerer refreshes the phone measure on all datasets. In general, our localization results precede other SOTA methods. This figure demonstrates the quality of the density map and the localization outcomes in practical scenarios. In the crowd scene, regarding object localization, steerer displays greater generalizability in detecting large objects in contrast to the baseline. Additionally, steerer maintains its efficacy in identifying small and dense objects. See the yellow box in Figure 4 remarkably. The proposed steerer model exhibits transferability across different domains, such as vehicle, tree, and maze localization and counting. Thanks for your listening. If you have any question, please feel free to contact me.